Hello students, welcome to World of Chemistry. This is Dr. Vikram Panchal and topic is chemical kinetics. And in this lecture, this is lecture number 6. Okay. In previous lecture, I was discussing about uh, differential rate law for any particular reaction. Suppose we write this reaction AA plus BB gives CC plus DD. And for this differential rate law will be rate is equal to minus 1 upon A dA by dt or minus 1 upon small b dB by dt is equal to K A raised to X and B raised to Y. Well, small a and small b are moles of A and B respectively, but here we write X and Y. And definitely X is not equal to A and Y is not equal to Y. Then what is X and Y? So we refer X and Y as order of reactions of A as well as B respectively. Okay, so in this lecture I will discuss what is order of reaction. But before that we should know one more term which is very much commonly used in uh, this chapter, and that is molecularity. So what is molecularity? Let us see this one. Well, it is the number of molecules taking part in a chemical reaction. This is known as molecularity. Or in another term, or in another language, very simple language, we can say that the number of moles of reactants is known as molecularity. This is purely theoretical. Molecularity is absolutely theoretical. For above reaction, we can write molecularity is equal to number of moles of A and B. So we write small a plus small b. Similarly, for another reaction like nitrogen plus hydrogen gives ammonia. And for this reaction, molecularity is number of moles of reactants. So molecularity is equal to 1 mole of nitrogen plus 3 moles of hydrogen is equal to 4. So this is the molecularity of this reaction. Okay, and now we will see what is order of reaction. Okay, so order of reaction. If we want to write definition, the definition is the order of a reaction with respect to a reactant is the power of the concentration of the reactant to which the rate of reaction is directly proportional. Or we can say that the number of moles of reactant, that is the number of moles of reactant which can change or which can alter the rate of reaction, or which can affect the rate of reaction. That is called order of reaction, and it is purely experimental. So it is purely experimental. Matlab, if you carry experiment, then and then you come to know what is order of reaction of particular reactant in a given reaction. Okay, so for example, when we write AA plus BB gives CC plus DD, in this case, when we write differential rate law, that is rate is equal to minus 1 upon A dA by dt, or minus 1 upon B dB by dt is equal to K A raised to small x and B raised to small y. There x is equal to order of reaction of A and y will be order of reaction of B. Okay, so this way we know x and y, but x and y can be determined only through experiments, while molecularity can be found out from the given reactions. Whatever the reaction is given, from this we can write this one. So we'll take few examples in which we write everything about these reactions. For example, twice NO plus oxygen gas gives twice NO2 gas. Now, according to stoichiometry, we write rate is equal to minus 1 upon 2, because 2 is the number of moles of NO. So dNO by dt is equal to minus dO2 by dt is equal to 1 upon 2 dNO2 by dt. So you can use any one of this. According to law of mass action, for the same reaction, we will write rate is equal to K NO raised to 2 and oxygen concentration. Okay. Now for this reaction, what is molecularity? So molecularity will be 2 moles of nitric oxide, 1 mole of oxygen is equal to 3. So molecularity of this reaction is 3. Now differential rate law for this reaction, we will combine stoichiometric relation and law of mass action. So we can write rate is equal to minus 1 upon 2 dNO by dt, or minus dO2 by dt is equal to K NO raised to x and oxygen raised to y. Okay, where x may or may not be equal to 2 and y may or may not be equal to 1. Okay, so here x is equal to order of reaction of NO, and y is equal to order of reaction of oxygen. Okay, we'll take one more example. Another reaction. Let us take this reaction. 5Br minus 1 plus BrO3 minus 1 plus 6H plus gives 3Br2 plus 3H2O. We write everything about this reaction. So first of all, stoichiometric relation. So here we write rate is equal to minus 1 upon phi dBr minus upon dt is equal to minus dBr03 minus 1 upon dt, or is equal to 1 upon 6 minus 1 upon 6 dH plus upon dt. Okay, we can write this one. Or law of mass action. For that we refer this one, rate is equal to K into Br minus raised to 5 BrO3 minus 1 and H plus raised to 6. Okay, so this is according to law of mass action. Now what is molecularity of this reaction? That is the total of number of moles of reactants only. So 5 moles of Br minus plus 1 BrO3 minus plus 6 of H plus, that is equal to 12. So molecularity of this reaction is 12. Now differential rate law. We write rate is equal to, you can take any one of this reactant, that is minus 1 upon phi Br minus upon, dBr minus upon dt, or minus dBrO3 minus 1 upon dt, or you can take minus 1 upon 6 dH plus upon dt. You can take any one of this, is equal to K Br minus raised to X BrO3 minus raised to Y and H plus raised to Z. So here X, Y and Z are order of reactions of Br minus, BrO3 minus and H plus respectively. Okay, so this way we can write different things about any particular reaction. Now I would like to explain you how to find out X, Y or Z, that is order of reaction. Okay, that will be in the next lecture. Thank you so much.